In this video, you will be learning about square root functions. A square root function contains the square root of a variable. For example, f of x is equal to the square root of x. It's better if I show you. Let's look at an example. It says, graph y is equal to negative 3 times the square root of x. Compare to the parent graph and state the domain and range. So look at what's written here. First, you make a table of values. You pick 4 values. In this case, I picked 0, 0.5, 1, and 4. Then we subbed in those values for x, and based on that we solved for y. And here the values are 0, negative 2.1, negative 3, and negative 6. And as you can see here, it's been plotted into this line. Now, when you're comparing to a parent graph, it's basically, the parent graph is f of x is equal to the square root of x. That's like the original graph, and you have to compare it to this graph. So, because it's a negative here, it reflects over the x-axis, and because of the 3, it's been stretched vertically. Now, when you state the domain and range, you have to look at the graph here. Notice how x is always greater than 0, and y is always less than or equal to 0. Sorry, greater than or equal to 0 and less than or equal to 0. Alright, so let's try an example to do for ourselves. It says graph y is equal to the square root of x plus 2. Compare to the parent graph and state the domain and range. Okay, so let's do the same procedure. Table of values. Let's do negative 2, we'll do 0, 2, and 4. Alright, again. Alright, let's use the calculator because, well, it's going to be simpler. So, alright, first, let's find out. Negative 2 plus 2 is 0. The square root of 0, well, is 0. So, our answer here would be 0. Then, if we subbed 0 for x, that would be the square root of 2. So the square root of 2 would be 1.4. So we're going to write 1.4 right here. Now, 2. 2 plus 2 is 4. The square root of 4 is 2. And finally, 4 plus 2 is 6. The square root of 6 is 2.4. So let's graph those. Now, when we're comparing this to the parent graph, notice how there are no negatives, no values outside of the radicand. So, we have to look at what's inside. Since it says plus 2, we know that it would be translated to the right by 2 units. So translated to the right 2 units. There. Alright, so the domain would be, look here. What is x greater than? X is always greater than negative 2. So, or equal to, greater than or equal to negative 2. Our range would be y is greater than 0, because notice nothing here is a negative. Y is, greater than or equal to 0. I keep forgetting. Alright, and that is how you solve that. Let's look at a word problem now. It says, an object has kinetic energy when it is in motion. The velocity in meters per second of an object of mass, m, kilograms, with an energy of e joules is given by the function v is equal to the square root of 2e divided by m. Use a graphing calculator to graph the function that represents the velocity of a basketball with a mass of 0.6 kilogram. Now, notice this has a lot of words. Don't worry about it. The reason why they give you a lot of words is to confuse you. So just look at what we're looking for here. It says that we have M representing kilograms, all right, and E is representing joules, right? So here's our function. V is equal to root 2e divided by m. And all it's asking us for is to find the velocity, v, of a basketball with a mass of 0.6 kilogram. So since it says m is kilograms, we have to substitute this m for 0.6. All right, that makes it a little bit easier. So v is equal to root 2e divided by 0.6. Now, this is a little bit of a complicated number to solve by hand, so I'm going to use a graphing calculator to graph. All right, so let's see. I'm going to put in a few values. So instead of v, we're going to make this y, and instead of e, it's going to be x. So y is equal to the square root of 2x, and that's divided by 0.6. And I'm going to zoom in so you can see what it looks like on a graph. And there, that is what your line looks like on a graphing calculator. All right, and that is it for today. Thank you for watching this video.